wanted your hand caressing it like you've been doing for the past minute.
They're so silky smooth.
Hey guys, welcome to part 2 of our lapping series. In this video we have Todd coming in. We got about 4 minutes of super nerdy speak about how the lapping machine works, and this was basically his training to us, like teaching us more how to do it. And then later Erik gets into it and shows his thoughts and you know, what he really thinks of the machine. So far we're loving it. There's a lot to learn. It's not as easy as we thought it was going to be, but whatever is. So enjoy.
Do people ever run it without pressure, or like super light pressure at first? I'm wondering if a light pressure will get rid of the burrs without like shoving them into the plate.
Lots of people do run without any weight. Usually it's more for a really high luster finish than it is for removal of burrs.
Yeah.
You should see, like, when it's probably harder to see on the waffle pattern plate, but your electroplated ring puts a pretty defined scratch pattern to it when you see it, and you know it's just been freshly conditioned.
You see that?
It's a lot more noticeable when you're on only an 8 radial groove plate or a smooth plate.
Radial grooves go like this, right?
Yeah, like pizza sections.
Right, and then there's the spiral that goes out.
And then spirals, Which radial we use like 99% of the time. Really. Yeah, because it's enough to allow the swarf that you're removing to get out of the contact area.
But then you have more flat area.
But then you have more flat area, and you get better surface finish, right? Now this, from a roughing standpoint, getting the part to flat so it's touching in all spots, this is the best pattern for it. Right. If you get facing in grooving, then you can change from one plate to another. So you could actually do, like, if you were roughing a bunch of parts for 2 or 3 days, you could put a waffle pattern into it, and then you could set it at a different setting and have it just put in a spiral groove pattern for finishing.
Just make your own plate?
Yeah, so you can change it, and literally it's like 5 minutes. It's just the time of it indexing across the plate. Yeah, so the biggest difference with diamond as opposed to conventional, conventional abrasives usually aluminum oxide.
Right.
The biggest difference that you see is you have to flood the slurry on
a lot more
with conventional.
Right.
So a constant flow onto the lap plate, because the conventional abrasive doesn't actually embed into the lap plate. So it's just a rolling.
And they're cast iron lap plates usually, right?
Usually cast iron, that's right. And the abrasive doesn't actually embed into the lap plate. It just sits and then rolls between the part and the lap plate. So it's not the most efficient process to it. Plus, you end up having gallons of swarf afterwards to have to deal with. Also, in a lot of cases, aluminum oxide, you can get it pre-mixed, but the majority of your customers mix it themselves, so you've got that extra feature or extra issue you have to deal with as well, is knowing a good ratio of abrasive to lubricant when you're mixing it. So getting diamond in your pint bottles pre-mixed, when you actually first have a spray of the diamond onto the lap plate, that does what's termed a conditioning process onto the plate, so it actually embeds the diamond into the lap plate.
Nice.
So that each diamond grain you make maximum use out of it.
Right.
So it starts off nice and sharp, and it still stays in bed even as it rounds off. And then until you condition it with the electroplated conditioning ring, that's what cleans that old abrasive out after use. So it's much more efficient. And then also aluminum oxide kind of wears at a pretty drastic drop-off rate. So you could have a 6 micron or a 9 micron aluminum oxide, and within 5 minutes of a cycle time, it's acting more like a 3 or a 4 micron because it's worn down so much.
But diamond will stay 9 micron.
Diamond will stay 9 micron through the whole use of the grain.
Right, until it falls off and disappears, kind of thing?
Until it gets plucked away and a new diamond gets embedded.
So is most of the cutting happening from the embedded diamonds? I imagine it like little fingernails stuck in the plate, and then the parts going like this.
Exactly
But
right.
is there tumbling action with the loose diamonds as well?
Not really, a little bit. But again, it's so inefficient that it's really not having much of an impact.
Yep.
It's the embedded diamond that makes the big difference.
Cool.
Hey guys, so in the last video I was talking about, like, we just got the lapping machine and I was trying to figure out how to get it to work properly to do everything that we needed it to do. And since then we pretty much got there, and I was able to get it to a point where I could teach Sky how to, you know, do most of it for me, which is fantastic, because before, like with the blades especially, you know, we'd get them from a lapping company, and we've covered this before, but they just didn't do a great job with the surface finish. So then I would always have to go and grind the blades, like the flats of the blades, down so that they would actually, you know, get a nice tumbled finish without being in the tumbler for like 24 hours. But that process was always hit or miss. Like, I'd use various different methods to try to get it right, and like 80% of the time it would work right, and you know, sometimes I would throw things in the tumbler for 3 hours and then pull it out and realize like there was a deep scratch from the belt, because belts are just incredibly inconsistent. So with the lapping machine, what that does is it's 100% like consistent. As long as you don't, you know, gouge the plate or get any contamination on the plate, you're not going to have any deep scratches on the surface of your part. So that way, once you get it figured out, you know that you can just throw these in the tumbler for an hour and they are done, like 100% every time. And I don't have to spend 20 minutes a blade myself, just trying to get the surfaces flat and pretty. So that saves me a lot of time, and makes the parts way prettier. Like before, I used to grind the flats after we cut the bevels. So then if you know, if it was a little warped or something and I ground away up here, it would look a lot more uneven from, you know, side to side. Whereas now we're cutting the bevels after they're already flat, parallel, and just perfectly finished. So they just look crisp and exactly the way they should now. So I've talked a lot about, you know, the upsides to the lapping machine and all the benefits that we've received from it so far. But there are some, you know, not necessarily downsides, but some things that we weren't quite expecting. Like, for one, the mess, it's really messy. That diamond paste or slurry is really hard to get off, and it just like coats the whole sink and the parts, and it's pretty gross. So gloves are highly recommended. But, you know, that's not a huge issue. It's just a bit messier than we wanted. And also, like, you have to maintain the thing a lot. Like, you have to keep the plate conditioned and flat. And we found that, like, possibly we have the wrong material of surface plate. It might be too soft. But we're finding that, like, when we're running the blades, it's actually making the plate really concave. Like, it's supposed to be 100% flat, basically. But now we're getting, you know, a lot more concave in it. So we've got to just make sure we keep an eye on that and measure it, like, every time we run it, just so we can keep it in range, because the further it gets out of range, the harder and longer it takes to get it back. Like, I think we've been reconditioning the plate probably for a good 4 or 5 hours today, just to try to get it back into a good location. So that's something to keep an eye on. And another one was keeping the individual pods spinning freely all the time, because we have the pneumatic arms that go down and push on the parts, but that ends up binding a little bit, so they don't always spin perfectly freely, and then the parts just kind of hydroplane and they don't get surfaced, you know, properly at all. And so that's another thing we're trying to figure out with positioning of the rings to see where it's going to keep spinning better. But, you know, all that's a little bit of trial and error, and other than that, it's working great. Nothing is ever going to work out as perfectly as you expected it to ahead of time. You know, there's always going to be more issues and, you know, more learning curves than you expected. But I love the machine. It's great. And this one is also a loaner, so like I think it's a 2012 model that they've been using like in their shop just to test parts for customers. So that might, you know, it might make the bearings on the pneumatic rods like not spin as freely, so that might be helping bind the pods themselves. So maybe the new machine will be a little bit more consistent and easier to run. But for the most part, it's easy. You just got to keep an eye on it.